All right, we're back. We are COMP397 in the winter 2020 semester. This is for the regular group, and it's lesson 2, part 1. We're talking about TypeScript today a little bit, and we're going to get into a review of what we did last week. So before we start, I want to talk about the project a little bit. New people have come into our groups because in the first couple weeks, things shift around, and we have some new people joining, some people leaving, and which happens. And what we have, I just want to go review the final project again, for a couple minutes. One is we're building a little game, like we talked about last week. We also talked about last week about different development roles in the video. We talked about you can be everyone's a programmer, but you have to choose one of software engineer as a lead, a producer, artist, sound engineer, game designer, or QA tester. So those are the different roles you can choose in addition to you being a programmer in general. And these roles, what they do is they make it easier for you to find your role in the team. Again, like I said last week, we kind of set up the ability for you to become in a team. There is at least 50% of our course is teamwork, and if you look at the schedule, we're sitting at week 2. Today, your part 1 of your project, your team contract is due tonight at midnight. So, if you don't have a chance to finish that or even start that for some reason, then your team contract is due tonight. It's worth 5% of your final grade. I've created groups on eCentennial. So, if you go on eCentennial, there are several groups. And there's some, you can auto-enroll to one of the groups. Group sizes, as I spoke about earlier, the minimum group size that I would accept this semester is 3, and the maximum being 6. So any group between 3 and 6 in size would be accepted. Anything smaller than 3, so if you only have 2 people or 1 person, that group will not be accepted and cannot submit. And why? Because we want to try and foster a group environment. So I said like 50% of our work is group work. So part 1 is today. Part 2 is next week. And I want to talk about part 2 next week a little bit, for next week a little bit more right now. So in part 2, again, you're making one of the 3 games that I talked about. In part 2, you're going to do a couple things. One, you're going to present with the rest of your team. And what you're going to be presenting is a little PowerPoint presentation, and the presentation is going to have several slides. The first slide is going to be your team name and your team logo. The person that's presenting, and people have asked me this before, I only need 1 person out of your entire group to present. The best person who wants to present, the person who loves to present. If you're going to put him up here, someone who doesn't like to present, the results may be mixed, right? So also sometimes what groups like to do is come up here all together to present. I don't recommend this, because what's going to happen is if only 1 person talks and the rest of the people have their hands in their pockets, that's also not that effective. So I only need 1 person to present. He or she is going to represent the team, and they're going to be talking about their game concept for next week. Now, as most of you are not game students, right? What I'm looking for is structure. So I've structured the PowerPoint presentation so that it has this. The 1 slide is your team name and your team logo, like it says here. And that's probably the most businessy it's going to get, right? I don't want a business PowerPoint presentation. So what I mean by that is, don't give me walls of text and lots of bullet points. I'm not looking for that. I'm looking for images. I'm looking for, to describe your game visually, right? More than anything else. Because this is a game presentation, a game pitch. It's not a business pitch. You're not pitching to RBC, a bank, or some kind of business thing like Microsoft or IBM. You're pitching to me, you're trying to pitch your game idea, and so it has to be a little bit fun. So the second slide is your role slide, and in your role slide, I want you all to have pictures of yourselves. So actual pictures, not anime or some kind of fanciful picture. It has to be a picture of you. It has to look good. It has to be the same size as everybody else's picture, right? So, but what I don't want is like stretching or squashing of the picture to make it fit into a size. You need to be able to cut it out, maybe get a picture, cut it out so it fits, and put it up on the PowerPoint slide. So if there's 6 people, there's 6 pictures on this slide. Underneath each of the images, there's going to be the name of the person. So if I was going to put my picture up, it would say, here's my picture, and then underneath that would be Tom, right? And then underneath that, you're going to have, what is your role? If Tom was a producer, image, my name, and my role, Tom, producer, kind of thing. And then that's going to be slide number 2. Okay, the third slide and the fourth slide and the fifth slide, or maybe even more, right? It's usually the game designer that's going to help put these slides together, because the third slide is going to be your influences. So what other game, as an example, are you looking at, or games really inspire you? Things that you really love to make, and you're going to take that inspiration, maybe from an aesthetics perspective, how it looks, how it sounds, maybe how it feels. That's the inspiration. And maybe how it plays. You might like the gameplay or the game feel. And you're going to put images of your favorite games, the games that you're going to use for this semester, to help you kind of guide you in your production of the game that you're going to make. Again, I mean, this is just the things that you like. I don't expect you to make a fully polished game that you're going to sell or anything like that this semester. That's not the exercise. The exercise here is you're going to learn how to make games for the web platform. That's what you're doing, using TypeScript. That's what we're going to be using. Okay, so your influences slide, one slide. Then your game overview. What is your game about? And again, last week I talked about you're going to have to pick one of these 3 game types. So whether it's a top-down or side-scrolling bullet hell shooter kind of thing. And it says 2 to 3 members, but like I said, I want the minimum size of all groups this time around to be 3. If you wanted to have 6 people do this game, I'm okay with that. The only thing that I'm asking for from if there's 6 people doing a bullet hell shooter is you better have 3 good, solid, beautiful levels, right? When you're making this thing. And by the way, all games that I'm asking you to make have the following requirements. Some kind of start screen that says, okay, here's my game, maybe some music, and something like press start to start the game. And then that's a menu, right? And then the next thing that you're going to have is your first play level. Sometimes people want to make a tutorial level on the first level, so to help the player understand how to play the game. That's sometimes what they do, but you don't have to do that. You need 3 levels, 3 playable levels, right? So maybe a tutorial, maybe a first level, and maybe a boss level. That's it, okay? So this is kind of like a proof of concept. You're coming up with a game. It's not going to be complete. You're going to have 3 little levels and a start screen and then an end screen. So if your game is over, your player died or whatever, or if you didn't win somehow, you have the loss condition, right? Then you're going to go to the game over screen. The game over screen is going to allow you to restart the game. Okay, that's what it's going to. So there's really 5 scenes that you need minimum. Start scene, level 1, level 2, level 3, and your end scene. Okay? Now that seems like a lot right now because we're at the beginning, but you're going to build all those individual pieces as we go. Okay? So that's what I'm looking for. So for your bullet hell shooter as an example, if this is the one you chose, then again, you're going to build all those levels. One of the requirements for this one is a multi-stage boss. So again, because we're not game developers, not all of us are game students, right? A multi-stage boss would be, okay, so you have a big boss monster, let's say some kind of enemy that comes up on the screen, and then maybe you shoot it or you attack it somehow. It loses some part of itself, or some part of itself dies or whatever. Or maybe it gets hurt and runs away. There's different ways of doing that. Then it comes back. That's a multi-stage boss. When it comes back, it's healed a little bit, and maybe has another movement pattern or something else like that, right? Or maybe it has a different attack, right? So it comes back a second time. It only has to come back one time. So it dies, it gets frightened, you kill part of it, whatever. There's many ways to do this. It goes away and then comes back, and it has different things that it can do with you. So when I say distinct setting progression, this means that each level has to have a goal. So if you don't have a tutorial level, and if you have 3 levels, please don't give me 3 levels that are the same level, just different colors. That would be bad. Imagine that. I have a blue level, I have a red level, I have a yellow level. They're exactly the same. They're just the colors are different, but they're different levels. No. That's not how it works. You have to make it so that there's a reason why you have the levels in place. So it says a time challenge event or an endless mode is optional. So if you want to make something that's it's endless or whatever, like one level could be a long level, that's up to you. You should have also some kind of enemy movement patterns. So that means like your enemies can maybe move in a particular way. You can describe things as, with motion graphs or even code it. You can use a little bit of simple AI. We'll talk about some of those concepts in this semester. And multiple bullet types. Don't make bullets just shoot up or shoot to the side. Make sure that the bullets can shoot to the side, shoot up. You can pick up other kind of bullets things, make it more interesting. These are all things that you're going to develop over the course of the semester. So don't expect it to happen right away. So that's why, because you have all these requirements, 6 people is good. I can go from 3 to 6, no problem. I would rather have a small bullet hell shooter that is very polished than, a game that is like really complex, as an example, and then has no polish at all. It looks terrible, right? I don't like that one. The other option is to make a top-down tank game or a twin-stick shooter. So people have asked before, do I have to make tanks? What if I don't want tanks? What if I want to have, people? So people are the tanks. For example, I want to have giant robots, or I want to have, knights on horses. I want to have wizards, and I want to have fighters, and they have different loadouts, different ways of casting. So some wizards are blue, and they cast firebolts, and other wizards are red, and they cast, lightning bolts, or maybe the other way around. And they have different powers or abilities. Those can be tanks. They're not true tanks, but they act as different classes, different kind of objects that can come out. This can be a very generic game. Some of these requirements allow you a lot of flexibility to make different kinds of games. Also, one of the requirements is a 2-player local multiplayer. So we're not asking for networking. There's no networking involved here. So you're not going to use like sockets or anything like that to communicate with each other in different systems. No. That's too much. But you should be able to have 2 inputs for 2 different players. Maybe one player uses a controller or another player uses the mouse and keyboard. It's possible, and I'm going to talk about how to do that this semester. Distinct terrain with destructible objects. So your terrain, your environment, if you shoot it or you hit it, it can break. That kind of stuff. Or it appears to break. It's not really breaking. And then maybe some bombs, power-ups, abilities, something else that you're going to pick up to make your game a little different. So that is the top-down tank game / twin-stick shooter. All right, lots of options there. Again, it says 3 to 4 members. I'm going to say minimum 3, maximum 6. These are all having the same requirements now, okay? The last one, which I'm going to recommend not to do, unless you have a lot of interest in making platformers. Platformers, this kind of thing can be really challenging, like making a Mario clone with JavaScript. The jumping and the landing and everything else, you have to program that yourself, your physics. Now I'm going to give you some example of physics engines we can use. We can incorporate that later on. There are some other things, but it'll change the way we do things with JavaScript and Create.js. And so it becomes way more complex. So I would recommend not to do a platformer. It's there if you really want to challenge yourself. I will accept it, but you have to be really confident that you can pull this off with JavaScript because it's all code. There's no drag and drop here. One of the things we're doing this semester is there's no Unity, right? You're not using a game engine. You're making your own game engine, which means there's a lot of complexity here to make this happen. So please don't choose this version, this option, unless you really are intending to make a top-down or some kind of a platformer. Again, if you're going to do this, you need movement and jumping. There must be some kind of enemies, traps, obstacles, unique for each level. There must be at least one unique mechanic. For example, if you're making a platformer, maybe it's going to be a grappling hook platformer where you shoot a grappling hook and you swing from one thing to the other. Maybe it's a jetpack platformer where you switch on your jetpack and you fly to the next platform. Whatever it's got to be something different than just Mario. And of course, there must be power-ups. So not a lot of detail, and I didn't put a lot of detail in any one of these things, and I worked on this with Professor Wallace for a couple reasons. It gives you a lot of options to make different kinds of games, right? A lot of different options so that you're not limited. We don't want to limit you that much, but we want you to have some examples of games that you can make within reason. Remember, because you're using TypeScript and Create.js and the web, keep your scope low. Okay, so I don't want your scope being really, really huge here, because you won't make the game. You won't finish. There's too much to do. Speaking of scope, remember that your producer, whoever that you decide or elect for that person to be, the producer has to manage the project with some kind of tool, project management tool. And I recommend, because we're using agile methodologies in this course and Scrum most likely, that you use some kind of tool like Trello or Jira or something like that that keeps track of each of your releases and your backlog as you're making out your game. And we'll talk about that a little bit next week. But your producer has a big job. It's a thankless job. It's a job that, because there's no teeth. It's not, the producer can't fire anybody. It's not like I can say, you're fired, right? If I'm a producer, you can't do that. You're going to more likely say, okay, here's your deliverable. What happened? Did you finish what you did? And by the way, let's track everything online. So the producer has kind of a lot of work. One of the things that the producer is going to be responsible for is making sure that all the deliverables for each of your projects are met. So that means, like for tonight, as an example, you have your contract that's due tonight. The producer should be the one to upload it to eCentennial. All of you should be part of a group. Is anyone not part of a group? Or is anyone here that's never been here from like last week? Are you a new person this week? You're a new person. Did you sign up for the group though?
Yes,
Okay, if you sign up for the group and you're enrolled in a group because everything is auto-enroll, you're all good. If you haven't done that yet, you need to do that or else you can't get credit for your project, right? So again, the groups can be found if you go up on eCentennial. This is for people who are not here. If you go up on eCentennial, so let's say if I look at communication and if I look at groups, I've created several groups, you can see, and there's some of them that are free. For example, group 4, there's nobody there, right? But some groups have group members of a minimum of 3, maximum 6. And you can see there's some groups that are completely full, 666, right, as an example. And that's normal. It's okay for that to happen. So there's a couple groups that I've left empty. So you can kind of, if you don't have a group yet, you can create one. But again, you can see that the minimum size of the groups are 3. Okay, so please sign up if you haven't done so already. All right, so that's your games, and going back to now my PowerPoint. So next week, so you're making your game overview. So what game am I making? Is it a top-down, kind of tank game? Is it a bullet hell shooter? Are you going to be brave enough to make a platformer? Which one is it that you're going to make? Talk to me about that game. Then MDA is your mechanics, dynamics, and aesthetics. So mechanics are how I play the game. What are the rules, right? Dynamics are how do I win the game? Is there a winning strategy? Is there something I need to do? Do players have to go through a process, to win the game? Is there something that they have to do? For example, collect bullets. I can't fire bullets unless I collect bullets. And then there's ways of collecting. I'm just making this up here. Maybe there's some rules to the game. Just like if you play a board game, you play Monopoly or Risk or Scrabble or something else, even chess. There's rules to the game, but there's also strategies on how to win, right? For example, in chess, one of the main strategies in chess are you control the center of the board. If you control the center of the board in chess, you have a higher chance to win. That's a strategy, right? Or a dynamic. And then aesthetics. How does the game look? Does it look like this other game that you're being influenced by? How does it sound? Does it have interesting sounds? Does it sound creepy if you're making a horror kind of game? Does it sound exciting because you're shooting a lot? Does it sound sad because you're making that kind of game? Like how does it sound? What do they sound like? And that's kind of like the aesthetics. And what you want to do is kind of make the dynamics, mechanics, and aesthetics almost like, even though they're called MDA, it's like the DNA of your game, right? So that's what it is. It's what makes up your game, right? So MDA could be 3 slides, could be 1 slide, could be lots of slides. Remember, you're still only going to have 5 minutes to present next week. 5 minutes. You're going to show your game, your concept. Your presenter's going to talk about it, and then people might have questions. And I'm also going to give you a little survey to fill out. When you're watching somebody else do their presentation, we're going to mark everybody on, hey, what are my materials like? Do I have good materials? Are they businessy? right? Or do they look like they're fun? Do I understand what game the person wants to make? The group, do I understand the game, you know? The other thing is, how does the presenter speak? Can I hear them? Do they speak down here? Are they afraid to be up here? Are they nervous? You know, like that's why get your best presenter. Your best presenter should be the one to present. And when you're presenting, you know, your presentation should be like this. I'm making the best game in the world. My game is like a game everyone wants to play, right? Like one of those kind of things. And the reason for this is I want you to think about like almost like you're selling your concept, you know, when you're doing this game pitch. It's a really good thing. Planning, there's one slide for planning, and the reason why I asked for a planning slide for this presentation is I want to see how you're thinking. So this is a producer slide. So you're going to go up on inside your schedule here and sit there and say, okay, look, next week I'm doing you know, my game pitch, but my part 3 for my project is due week 5. That means you have 2 short weeks to produce your first playable release. First playable means you have a little bit of movement. You see some of the assets that might be used, and we have an idea of what kind of game you're making. Just very little, right? It's just the first playable build is just I can play the game, but I really have some pieces that are missing still. And all of my assets may be placeholder. Maybe I got the assets from somewhere else or whatever. They're not even the complete assets or the final ones. I just want some movement in the game. And that's your first playable build. So that means you have 2 weeks to do your first sprint, right? Because we're using Scrum. You're going to do your first sprint, 2 weeks. Then you're going to produce your release. Alongside your release, you're going to do a peer review. Peer review number 1 is due next week. It's going to say, so how did we do? Did we come together? Did we make the meeting, the first meeting? How do we do it? Peer reviews are individual, and they'll allow you to discuss how do you feel about how your group is working. Is everyone working? Is someone not working? Are you not working? You know, you talk about this. If you don't hand in your peer review, you lose 1% of your final grade if you just decide not to do it. And then part 3, peer review number 2. Again, that's week 5. 2 weeks later, you're going to come up with your alpha release. Alpha release has start screen, at least 1 level, and an end screen. That's what your alpha release has, at least those 3 things. So by then, you need to know how to move from one scene to the other scene in JavaScript. You need to know how to do that. Okay, so that is your alpha release. And then after the midterm test for your project, your next release is your beta release, and it happens on week 10. But week 10, when we were talking about 4 weeks later. Why? Because this is week 7. Week 8, really, we're off. It's not really a week 8. Then we come back for week 8, right? So this is physical week 8, but not learning week 8, right? So week 8 happens the week after the break, right? Week 8. So you have week 8, week 9, and week 10, which is 3 weeks for sure, plus your break. So if you work during the break, you can have almost 4 weeks of development to go from your alpha build to your beta build. That's what happens. So your beta build is due on week 10. And then between weeks 11 and 12, like I said last week, we're going to have a little bit of a playtesting session where every group playtests every other group's game and gives them feedback, right? Did we do a little bit of an evaluation, a game evaluation, give the groups feedback, and then if your group gets feedback from other people, and for example, let's say the user interface is no good, or maybe the gameplay is too difficult or not fun, and you change something to make it better based on the feedback that you got, I'm going to give every group that does that 5% bonus if you take feedback and make your game better. And then whatever you do, you incorporate it into the final release, which is due week 13. So that means you have 3 weeks between week 10 and week 13 to make your final release. And after week 13, there's no more code. Code is done. That is your code freeze. All right, so there's no more, nothing's happening. And then on week 14, you're going to do a final presentation. Your final presentation, you're going to take your game. The same presenter, chances are, is going to come up here again and talk about your game again. Some of the things you're going to talk about are based on the things that you talked about before, the first things. One group member asked me earlier today from a group, they said, what if my game is totally different than the game I pitched to you in week 3? It's okay. Because there's so much iteration going on, right? The great thing about software engineering is we have a lot of uncertainty right now. We don't know if we can do it. We don't know really what we're doing. We have an idea of what we want to do, and we're moving towards that idea. So the game that you pitch and the game that you produce might be very different, okay? And some of you who have done other classes with me know that happens sometimes. You start off and you have an idea of what you want to do, and then the final product is not what you intended, or different, better than you intended, right? So your final presentation replaces your final exam. There is no final test or exam in this course. There's just the final presentation, but you must attend it. There is no way around it. You must attend this thing. It's mandatory attendance, as well as next week. Next week is like a little test. Mandatory attendance for your group members. If you don't attend, you can't get any marks for it. That's how it goes. And why? Because there's two parts to the attendance when it comes to presentations. The first part of the attendance is the actual presentation itself. And the second part is your evaluation. You're going to evaluate everybody else's presentation. So if you're not here physically, you can't get a mark. Okay? So that's how it works. So you must be here on week 3. Week 3. Those 2 weeks and your midterm tests are the 3 weeks you must attend. You must attend those 3 weeks, right? Because next week is kind of like a test. Your midterm test is a test, and it's individual, right? So you're going to be doing a test physically in class, and your final test, or which is really your final presentation, is like a test or an exam, right? So that is how it goes, all right? When it comes to that stuff, the rest, as long as your team knows where you are, you follow the PowerPoints and you do your individual assignments. And there's 2 individual assignments in this course. Assignment 1, which is due week 5 for now, worth 12% of your grade, and assignment 2, which is due week 9, also worth 12% of your grade. You do those individual assignments and your exercises. I haven't done really exercise 1. I'm going to leave that. I want to wait till you guys after this week to do an exercise where you hand something small in next week that can show me that you know how to do Create.js and a little bit of TypeScript. I want you guys to get your feet wet this week and practice, right? But every exercise you do is worth some individual component of your mark. So for example, in week 4, we're going to be talking about finite state machine pattern, where we're going to create different scenes. Scene 1, scene 2, scene 3. We're going to talk about it. You're going to hand something in to me, to show you that you know what you're doing. And then collision detection and response. You can't make a game without collision detection and response. That's going to be due week 5, right, as an example. And again, I know I talked about this last week. I'm going over it again because there's some new people, and I want to make sure that people know what they're doing. So again, tonight, just to finish this off, because I want to get to coding and everything else, right? And I also want to redo some of the setup from last week. Again, practice one more time. I like to do it twice, first week and the second week. Then after that, we're going to just reuse some of the stuff we've already done, okay? Because we need to get coding, right? But for tonight, you need your first draft of your contract. That's due tonight at midnight. And what I mean first draft is you may have people leaving your group. You may have new people coming into your group or moving from one group to the other. It may happen. So you may have to revise your contract yet again, right? For example, today, maybe some people left the course, right? As an example already. And they've left your group. That's okay. You have to revise your contract before you hand it in, or if you've already handed it in, hand it in again with the revised grouping, whoever people that are in your group. Make sure that is updated. And then next week, like I said, make sure you work on your PowerPoint presentation with your team. I recommend spending some time planning at least 1 hour a week together with your team, whether it's remote, although I recommend face-to-face where you can sit down together and work on your project, right? Because you need to do that. So next week you're going to do your PowerPoint, you're going to pitch your game. So make sure you're here next week. It's mandatory attendance. Any questions around the schedule? I know I went through this one time last week and again this week. I have to do it a couple times because that way everyone can be clear, so no one can say, well, I didn't know, right? I want to make sure you know because it's important. And that way we can make this thing fun and we can evaluate everybody fairly. Okay? So that is the timing. So no questions? I'm guessing you guys are all good with this?
Presentation work is out of the class, right? particular part, but still we need to finish our presentation.
So the presentation that you're going to be doing is, so let's say for example, you get together between this Saturday and next Saturday, right, with your team,
Yeah.
and then you create your presentation, right? So that's the material part of your presentation.
Yeah.
But let's say next week you're presenting. Maybe not. It may not be you who's presenting. Maybe it's somebody else. But you still have to be with your team that day. That's what I'm saying. As long as you're here with your team physically, and then you can look at other people's presentations and give them some kind of response, some kind of feedback, you've met your requirements for next week. Okay.
Before the class time, we need to finish.
Yes,
to
before
prepare
the
slides.
presentation. Yeah, because otherwise, if you don't have it before, you can't finish it during. It's the first thing we're going to do is your presentations next week. Okay. We're only doing 2 presentations, next week and the final week. That's it. Okay. Back in the day, I used to do presentations 4 or 5 times, but that's too much. So now it's only 2. Okay, so if everyone's good with the administration, let's put this away. So now let's talk about a little bit about the technical part again. Remember that we're using Create.js. That's what we're using. We're using Create.js, this part. And Create.js is a suite of libraries. It includes Easel.js, Tween.js, Sound.js, Preload.js, those 4 libraries. For the most part, we're going to really focus on Easel.js mostly. We're going to do some Sound and some Preload, and if we have time, we'll touch Tween. Okay, that's how it goes. Typically what I do. All the documentation for each of these libraries, if you click on a specific library, for example, Easel.js, and if you click Docs, you can see here that there is documentation on the left-hand side for any module or any class that it talks about in Create.js. So if you have a question on how things work with the framework, it's all online. It's the best textbook that you can have. It's right online. One person asked me earlier, what about JavaScript? We're going to be learning JavaScript, right, in this course. And the answer is, yeah, you'll have a little bit of JavaScript. It'll be way different than the JavaScript you may have taken before because we're not using kind of vanilla JavaScript in this course. We're going to move on to TypeScript. Let me talk about TypeScript a little bit. So if you go to TypeScriptLang.org, TypeScriptLang.org is where TypeScript lives. TypeScript, like we talked about last week, is a project that was created by Microsoft. Right, so it's not an independent company. It's a big company that made this new language. This language makes JavaScript better, makes JavaScript easier. And why it does that is because JavaScript by itself is unstructured. JavaScript is loosely typed and does not have fixed types typically when you create variables. It uses implicit typecasting, so typing, not explicit. You can't say in JavaScript, this is an integer or this is a float. You can't do that kind of thing. But TypeScript allows us to do something like that. It says this is a number, this is a string, this is a, and it gives us code hinting. So I'm going to kind of explore a little bit of TypeScript today with you, and then we're going to go into actually do some code. So let's talk about TypeScript. If you go to your playground up here online, anyone can do this. It doesn't require any installation. Let's click playground. And I've got some code in here. I'm just going to get rid of it. I want to clear this up so we can start from scratch. I have to talk about this. When I clear this up, there are several options in the playground, and this is somewhat new. Over the last little while, they've really improved the playground in TypeScript. And if you notice, you can choose the version of TypeScript that you're exploring. For example, I can choose version 3.72 or some earlier version. And also, we can choose the configuration. Notice that there is a target under the configuration. So what the target is the target of JavaScript. Remember that TypeScript is not something that's understood by the browser by default. The browser, common browsers, they don't know what TypeScript is. They know JavaScript. So what we do is we write things in TypeScript, and then we transpile into JavaScript. And transpile is a funny word. It's like I want to compile and translate from one language to the other language, or translate and then compile. Transpile. So when I do that, when I transpile from one language to the other, I have to have a target. What language am I targeting? And you're like, well, it's JavaScript, right? But there's different versions of JavaScript. Back in the day, we were working with ECMAScript 3. And ECMAScript, for those people who don't know, or maybe don't remember, is the language that JavaScript is based on, ECMAScript, right? And ECMAScript 3 was around the time when we had HTML4 and CSS2. Okay, so earlier versions of the web, you know, kind of environment. CSS2 is basic; it didn't have a lot of stuff, and HTML4 had some issues. It wasn't as responsive as HTML5. When HTML5 came out, they updated JavaScript, and this was around the early 2000s. I would say the mid 2000s, 2005-ish, you know, something like that. Towards 2010. Something like that. ECMAScript 3 moved to ECMAScript 5. And ECMAScript 5 had more features. And that's what all these versions have, more features. But it coincides with the release of HTML. HTML5 was a very powerful version of HTML. It used semantic elements, not just div tags and that kind of stuff, but other things to make, you know, your markup more realistic, more meaningful. Right? That's what HTML had. And CSS3 was way better than CSS2. It gave us a lot more options and a lot more performance. So that was ECMAScript 5. And it was good. But back in the day, we needed some additional framework. They were coming up with new frameworks, new front-end frameworks for JavaScript. And one of them, around, again, 2012 timeframe, 2011, 2012, was AngularJS. AngularJS, now just called Angular. AngularJS was a front-end JavaScript framework. In the past, we had different kinds of solution stacks. We had an AMP stack, Apache, MySQL, and PHP. And PHP still controls about 70% of the backends on the internet, something like that. Okay, 70%. But it's older. It's a little older technology, and it's becoming less and less favorable to program your backend server with PHP. Nowadays, what we want to do is we want to use JavaScript everywhere. JavaScript everywhere. So we use Node.js on the back end. The middleware is something like Express.js. That could be a common middleware. And for the database, instead of using SQL, we don't use SQL. We use NoSQL. A NoSQL database like MongoDB, right? A serverless database sometimes too. Maybe like Firebase, okay? So that's what happens in the middle. And on the front, we use Angular. So it's JavaScript everywhere, right? That's what we're doing nowadays. One other solution stack, so that's the mean stack. Mongo, Express, Angular, and Node. And you can replace Angular with React or Vue or something else, okay? Because there's different kinds of front ends you can place in there. So that's the mean stack. Mean stack, AMP stack, and then Microsoft has its own stack. Microsoft uses IIS, Internet Information Services. That's the server. That's like Apache, right? It uses SQL Server for the database, right? And on the front end now, it uses .NET Core for its middleware, for its routing, as well as Razor for its front end. That's what it uses. And if you took COMP397, if I'm not wrong, then it uses that .NET Core ecosystem, okay? However, with .NET Core, you can replace Razor with AngularJS on the front end or React or whatever else you want. So because there was this revolution happening and we had JavaScript everywhere, JavaScript needed to evolve even more. So around 2015, they came up with another version of JavaScript called ECMAScript 6. And it was ES6, but the thing is, you know, they started saying, well, we need to update this more regularly. So imagine we're going to do ES6, ES7, ES8. We could go with that, but maybe it's better, instead of having that number system, to use the years. So ES6 became ES 2015. So 2015 was the year where things started to change. It's almost like JavaScript woke up again in 2015 and started evolving. Every year they've added new features to JavaScript. So 2015, 2016, 2017, all the way to 2020 now. And ES Next showing us the next version of JavaScript. It's like a nightly build of the latest version of JavaScript, whatever that is. So we can target those. So TypeScript can target any one of those versions, right? For our course, for now, we're going to target ECMAScript 5. And I'll tell you why we're going to target ECMAScript 5. ECMAScript 5 is supported by 99.9% of all browsers out there, okay? The browsers we care about that we want to support are Chrome and Firefox right now. Those are the two browsers we're going to support. If you're used to using Internet Explorer, hopefully not, and hopefully not in Microsoft Edge, take those two browsers away. We're not going to use those browsers. We're not going to support those browsers with what we're doing in this semester, this course. And Safari, I like Apple Safari. I do like it, but it's been left behind a little bit when it comes to development. So we're not going to target Safari specifically. It can run some of the stuff we're doing, but we're going to leave Safari behind. So if you're a Mac person, please use Chrome or please use Firefox. Those are the two browsers that we're going to talk about. Myself, I'm going to be using Google Chrome throughout the entire semester, and I highly recommend it for you too. Just make it easier. Okay, so Chrome runs ECMAScript 5. It runs ECMAScript 6 really good too. But let's suppose if you're going to make something on the internet that you want to have more people use, your program to be compatible with more users, let's target ECMAScript 5. Okay? Eventually, maybe next year, if we continue with this, we're going to move this to ECMAScript 6. We're almost there, I would say, for coverage. I would say there's still 90% coverage with most browsers. Module. Module is the way we connect multiple files in our project. Right now, there's different kinds of module patterns. We can have a module loader ahead of time, and AngularJS as well as React, they use a module loader pattern that kind of loads up all the modules for you. So for example, when I say module, I mean external files, your own external files. You make your own class, and then some module loader loads up the module. We're not going to do that. We're going to use CommonJS. Right, so that's going to be our module loader. So those are the options we're going to use. Obviously, we're not using JSX. JSX normally is used with React. We're not going to do that. And then there's some other options we're going to turn on for the tsconfig.json file. These are the options we're going to turn on, and I'm going to talk about this. So this is great. So the playground has actually given us some really great options here by default that allow us to test things out online without downloading anything, which is great, okay? So let's talk about TypeScript. TypeScript is, like I said, it's structured, right? It's like looking at a web version of C# or some other language. Let's talk about the structure. So imagine if, and I want you to do two things when you're doing this. The left is going to be TypeScript. The right is going to be traditional JavaScript, ECMAScript 5, because that's what we're targeting, ECMAScript 5. So let's take a look and see how that works. So if I start typing the keyword class, let's do it together, class. And I want to make a class person, okay? My class person is going to use a constructor. I'm just going to, kind of use some pseudocode here or some comments. And also it's going to have one method, all right? So my constructor, when you make a constructor, it looks like this, constructor. You type the word constructor in there, and let's say my person has two properties that I want to have. One property, I'm going to use the keyword public here, is going to be the name property, which is going to be of type string. Notice I said that. I said name, colon means of type, name of type string, right? And then I have an age, public, age, of type number, okay? And then some curly braces. Yay. All right, cool. So I've got a couple things I did here. Wait, look at this. This is what it's going to look like in ECMAScript 5. Easy. Not so easy, right? And this is looking messy. It's still okay at this point. I think it's still okay. I think you understand. And if I change my config, I just want to show you this. To be fair with JavaScript, the current day JavaScript, if I change my config, so I targeted ECMAScript 6, which is 2015, instead of ECMAScript 5, you can see that we have very little difference between this and this. The difference is here. Because JavaScript doesn't have any type system right now in place, it's not strictly typed at all like TypeScript, you're always going to get this structure. Notice that there is no type. Even though I put types here, there's no types over here. Let me go back to ECMAScript 5 for a second, and let me talk about this. So some people have always asked me this. So then why bother? Why bother putting types if it gets transpiled and there's no types? Because in reality, it's not going to matter. But actually, what I really use TypeScript for is not necessarily to make sure that the types transpile into JavaScript, but that I get good code hinting, that I get those squiggly lines that tell me there's an error here, right? I want to get good tooling, good code hinting to help me debug my code, because when I make a large application, which we're going to be doing is somewhat like of a large application over time, we're going to build up a larger application with TypeScript. I want good support. I want people to know there's an error. In JavaScript, JavaScript won't complain. You can make mistakes all over the place, and it's just going to accept it. We can't do that, guys. Not in this. It's going to kill us if we had no support. There's no debugging whatsoever. Well, there is, but it's more difficult. And methods. How do methods work? So if I have a method called, let's say, says hello, I can say that the method returns void. That's how you do it. So again, colon is returns, or the method is of type. You can say it that way. And in my method, I can use the latest version of JavaScript's template strings to do something like this, console.log. And then I can use the backtick character, which is the character underneath the escape key. So backtick. And I can say that if I use $ and curly brace, then I can say something like, well, name, right? And I can say this dot name, this dot name, right? Says hello. This dot name says hello. Okay? Now take a look at the JavaScript side. So remember before it wasn't so bad. Now, well, that's what a function looks. That's what a method looks like. So we have person, which is the person class, prototype, which is basically saying I want to add to the person prototype a method called says hello, and it's going to use an anonymous function that we're going to use. Instead of using string templates or template strings, we're going to use string concatenation, just like the old way. This way injects or interpolates the name variable. It interpolates or injects it inside of the string. Here, you just add these two things together, and then name becomes a string for returning this out. It actually converts name into a string and outputs it to the log. Okay, so this is the person class, right? And this looks nice, not so nice, right? That's what I'm telling you. Okay, so now if I instantiate an object, I do something like this. I say person, let's just say Tom, and we say let. We use the keyword let here. We'll talk about this in a second. Let Tom, which is a type of person, equal to a new person. And Tom needs two inputs. One of them is a name. Another one is an age. Another one is an age. Let's put an age. I'm going to say 40. Not true. Tom is not 40. But let's suppose I would love to be 40, so I'm putting 40 in there, right? Oops. And that's cool. And then I want to say Tom.says hello, because that's what I can do, right? So Tom says hello. Okay, so take a look at this side, and now take a look at this side. So this is much more complex. And this is why we use this as well. So easier to code, good code hinting, good tooling, tells us when things are wrong. TypeScript. Challenge though, cons. So positives, we get a lot of positive things. On the negative, you need to set TypeScript up. I need to have a tsconfig.json file. I need to have TypeScript installed. I need to be able to transpile from TypeScript into JavaScript. There's some steps, but when you set everything up for the first time, it becomes easier. And then it outputs this perfect JavaScript that's going to work across every platform for the most part. I can also run my code. I can run here. If I click run, it says check the console. And if I right click up here to check the console, so if I go inspect, and if I look at the console, let's take a look at the console. You can see that it says Tom says hello. Yay. So whatever I do here, it kind of appears, right? Right here in my playground. So this is great. You know, my playground works okay. Now, this is where it gets interesting. What if, does person really make sense for a class? I mean, if you use object-oriented programming concepts, person is really generic. I want a specific type of person. I want a student or a professor or something like that. That's the kind of person I want. So I can get rid of this for a second. Let's get rid of this. And let's talk about that person should be abstract. We can use the abstract keyword like this. And when we use abstract, what it does is it hides the person so you can't access it. Take a look at what's happening here. So if I don't have abstract, let me just take this off, right? And then if I do have abstract, oh, how about I do it properly? How about it's abstract? So if I do have abstract, nothing really changes, right? But here's where the change comes in. Watch this. I want to make a new class. The class is called student. Okay, so here's the person class, here's the student class, and my student class, here's something, extends the same keyword we use in Java, extends the person class. Oh boy. Oh man, it's going to get really messy now. All right. Take a look at this extends thing to make extends work. Woohoo! Right? That's like a utility function that gets generated by this thing, and it looks really terrible. Look at this. This is extends. This is extends. Right? Just to type this keyboard in. Right? Now, to be fair, if I convert this back into ECMAScript 2015, then, well, it becomes a lot easier again. Like this. It looks like this. Extends is actually a word that browser understands. Okay? Let's go back to ECMAScript 5 for a second, though. So this is what it looked like in ECMAScript 5. Really ugly. Like this. Okay? And let's continue. So yes, it extends person. I want a new constructor. So here's a constructor function. As well as I have a methods, a group of methods. My constructor is going to look like this. I'm going to say constructor. I'm going to pass in this time a public name, which is of string. A public age, which is a number. And maybe a public student ID, which is also a string. Okay? When I do this, TypeScript says something's wrong. Something's wrong because I have a constructor and I'm inheriting from person. I need to satisfy its super constructor. So I'm going to put the keyword super in there. And my super constructor is going to take name and age, which satisfies the requirements, right? And then in my methods, I'm going to have a new method called isStudying, which also returns void. And isStudying is going to be very similar to says hello, in that instead of this name says hello, we can say that this name is studying, right? Excellent. We're cool. And now when we instantiate at the bottom, we can say that let Tom be a type of student, right? Equal to a new student this time. And I want to take his name and his age. Let's put the real age in there, 50. And his student ID, 1, 2, 3, 4, 5, 6, 7, 8, 9, A. Let's say it's alphanumeric. And there we go. That's Tom. And we can say that Tom dot both says hello as well as Tom dot is studying. We can do both those two things. Even though says hello was part of the person class and is studying is part of the student class. Here's a student class. We can do both things, right? Because Tom is a person. It has an is-a relationship with person, but it's a special type of person, which is a student. And remember that how OOP works, object-oriented programming, right? The parent is a certain size. It has a certain memory footprint. But the child class is always fatter than the parent class, okay? And I said this a couple times this week, and it can be seen pretty funny when I say that the child is fatter than the parent, right? But really, it is. The memory footprint for the and the usage footprint for the child is much bigger than the parent. Why? Because the child has additional things. It has everything the parent has plus some specialization, right? Which means it's bigger typically. Now take a look at this code. So here's the difference. So here's my person class, and here's my student class, and this is some usability. And wow, look at all this crazy stuff right here. It's insane what I have to look at. So way more difficult. Again, to be fair, if you convert this from ECMAScript 5 to ECMAScript 2015, it isn't so bad. It's much better. ECMAScript 2015 is way better. That's why we keep evolving JavaScript slowly. And I think one day TypeScript will not be required anymore because all the features of TypeScript will be in the latest version of JavaScript. So you won't need it anymore. For now, though, you do need TypeScript because of typing, because of good code hinting, because of many things. So yeah, this is ECMAScript 2015, which is better than ECMAScript 5. But if I go back to poor ECMAScript 5, you can see how crazy it is, right? It's pretty crazy and it looks pretty ugly and it's difficult to deal with and hard to maintain, right? If I was to run this thing now, so again, I'm going to run this code and I'm going to check my, I'm just going to check my, my console here. Let's check my console. You can see now that Tom does both things. Tom also not just says hello, but Tom is also studying because that's what I've asked Tom to do, right? Which is pretty good. So that's how it works. We make TypeScript, we transpile into JavaScript. It makes good, perfect JavaScript, maybe some of it that you don't understand, right? But that's okay. And then we have good code. And it works across 99% of all browsers. And that's how we're going to make this web programming stuff work, right? Web game programming. Questions around TypeScript?
Could you show the class student please again? Yeah.
The student or the person?
Student.
Is a student.
Yeah. And what is the last parameter in the constructor?
Oh, I can't show you, but the last parameter in the constructor, here, let me just, I'll break this up over 2 lines. It looks like this here. Here. Yeah, here, let's do this, and let's just make it look like this so you can see it. So here's the, you can actually do this nicely, right? You can make it so that the constructor breaks down over 3 lines. It doesn't really matter. I mean, it's just formatting, right? So I've just added name, age, and student ID, and this is just this is my typical example when I want to show object-oriented programming format. It's not really object-oriented. JavaScript uses objects, but we use prototypal inheritance as opposed to classical inheritance. But we're going to try and make it so it feels like classical inheritance in JavaScript using TypeScript, right? So it's easier for us. If you're a C# developer, this is easier, right? If you're a Java developer, easier, right? If you've programmed in JavaScript before, then, well, it's still easier, right? So TypeScript is JavaScript, but just better, right? So that's why I use it. So that's TypeScript in a nutshell. If sometimes what happens is this. One thing I should mention is a couple things. One thing we'll do in this course is we'll use the keyword let and const over var. I don't want to ever use the var keyword in our course, ever. You might see examples online where they use var, and they're even used here on this side. Well, this is old JavaScript. But here for us, no var. It's let the whole time. Where we can convert to ECMAScript 6 to make our code better, if we convert to ECMAScript 6, let's just go to ECMAScript 2015, you can see that it also uses let. That's the newer way to do it, using let over var. No var, right? And so we're going to use it so that there's no var as well. We're going to go back to ECMAScript 5 though. So the only different challenge with us when it comes to going to ECMAScript 2015 over ECMAScript going to ECMAScript 5 over ECMAScript 2015 is it uses the var keyword, which is for us a no-no. We don't want to use var. Why? Because var gets hoisted, right? If I declare something in a for loop, for var I is equal to 0, where I is less than whatever, let's say a number, value, I plus plus. And in C++ or in C# or in Java, the I variable lives and dies inside the var, the for scope, the for loop, right? Not so when I use var. If I use var in JavaScript and I make a for loop, that variable I lives outside of the scope. That's bad. That can cause bugs. That can cause errors, right? So we don't want that kind of thing. And that's why we want to use let as much as possible and const. Those are the 2 things we want to use. Okay, let and const. So that's one thing. So that's the way we're going to be programming. If you want to know more about TypeScript, and we're going to be using TypeScript throughout the course, go to documentation. And under documentation for TypeScript, if I click on documentation, you're going to see here there's a handbook. In the handbook, there's explanations about everything, how to do basic typing. So for example, it talks about basic types like, hey, this is how you do declare a Boolean. This is how you declare a number. This is how you declare a string, and so on. It has every documentation you can think of for TypeScript. So right here in the documentation for TypeScript, this right here, how to do classes. You know, it talks about classes. How do they look? How do I do things like, if you scroll down, how do I do inheritance? You know, how do I do things like getters and setters, accessors? You know, it's public by default. You know, I can use private. I can use the private keyword. How does that work? What does it do for me? It doesn't do anything on the JavaScript side because there is no public and private on the JavaScript side. What it does, give me good tooling. It gives me the little red underline saying, hey, this you shouldn't be doing this because this is supposed to be private, right? That's what it does for us, right? And it does a lot of other things too. If you keep scrolling down, even things like understanding protected, read only, we can use read only modifier. And if you keep scrolling down, accessors, TypeScript also includes accessors like get and set, right? So it does those two things too, right? So it makes the language very similar to C# or Java. So much more easier for developers like us to understand.
This is like
Yeah, it's what it is. And if you like Swift, if you're a Apple developer and you program in Swift, also very similar to Swift. So between Swift, C#, Java, it's a more structured language. It makes it much easier for us to understand. All right, so that's the language. That's TypeScript that we're going to be using, right? And that is with classes. Okay. So what I'm going to do now is I'm going to take a short break. Let's take a short break. We're going to go into about, let's say take about 10 or 15 minutes. And then when we come back, we'll start into the coding part. I'm going to redo the setup from last week really quickly. And then we're going to go into creating a module, a brand new module for ourselves, and start creating objects, right? Because one of the challenges we're going to have is we need to create a little mini game engine. That's what we're going to be doing over the course of the entire semester. It's not going to be a real game engine because, you know, a real game engine would have to have many more complex parts that would make our job a lot harder. But it'll be enough for you to have some fun. Okay, that's what it's going to be. One thing to note is I'm going to be at some point in this semester, I'm going to be making a small game that kind of looks like this, right? And this game here, Mail Pilot, is my Hello World game that I use across every platform. I make it on JavaScript, on C++. I make it with Unity. I've made it with Unreal. I've made it with Android, iOS, Python, right? Java with libgdx, and a bunch of other things. All right. So this is the site, mylastname.com, and when you click onto it, you see that there's a little plane and there's some clouds, right? And if I collide with the island, I get a bit of a yay sound. See? And if I hit the cloud, I explode. You know, the plane hits the cloud. The clouds are radioactive. I don't know. And every time it hits the clouds, they die, and then the game is over. So that is the little game that I'm going to show you how to make. Just not because I want you to make this game. I want you to understand the process. That's what I want you to get. And we're going to build this plus other games over the this semester, and so that you'll be able to make your own games. Okay. So this is what we're going to be doing. Again, not super exciting. This is just my Hello World, and you should have Hello World programs for different aspects of your software engineering. Example, I want to learn Android. What am I going to make? I'm going to make a calculator. I'm going to make a to-do list. My calculator is my Hello World to how to place things, how to do inputs and outputs, how to do calculations. You need to know how to do that kind of stuff. And then I'm going to make the same one in iOS. So if I'm going to make mobile, I'm going to do mobile development. I already know how to do a calculator in Android, then I can do one in iOS, then I can do it on the web, then I can do one on Unity, then I can do one in Unreal, then I can do one in 10 other things, right? Maybe I'll do one in my glasses one day when I have smart glasses. I don't know, right? Then I'm going to have a to-do list. My to-do list is going to have a list, plus it's going to have access to a database. Persistent storage. How do I do persistent storage on my platform? I want to know how to do that. That's going to be my next Hello World, right? And finally, if I'm making a game, I'm going to do this. By the way, I'm making the same game this semester on iOS with SpriteKit, right? Because I'm teaching iOS, advanced iOS on Wednesday nights, right? So you'll see the exact same game. If you actually look at the YouTube playlist, you'll see like me making this game with SpriteKit, right? Okay, let's take a short break, and when we come back, we'll get right into coding, and we'll do the setup one more time.